Okay, Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. So in this video, I would like to explain about the hydrohalogenation reaction in an alkene. Alright, so if we look at the name, so hydrohalogenation, hydro mean hydrogen, while halogenation mean halogen, meaning that this reaction is between H that represent hydro and X that represent halogen. So the general formula is, let's say we have an alkene undergoes reaction with HX. Okay, so what is your product? What is the expected product? So to predict the product for the reaction, we have one rules to consider. So the rule is called the Markovnikov rule. Okay. According to the Markovnikov rule, so this is the definition. Okay, according to the Markovnikov rule, in the addition of HX to alkene, okay, so means that the reaction is an addition reaction. Hydrogen atom added to carbon with more hydrogen atom at carbon double bond. Now let's focus on our functional group, which is carbon double bond. We have two, this carbon and this carbon. The carbon with more hydrogen will attach with hydrogen. So let's say I give you one example. Let's say we have this. Okay, now not HX lah, HBr. Okay, now we have an alkene undergoes reaction with HBr, so we know that we must follow the Markovnikov rule. First, let's focus on the functional group, which is carbon double bond, and then we have two different carbon. This carbon, okay, attached to two hydrogen, meaning that while this carbon does not have any hydrogen, meaning that the hydrogen will attach to the carbon with more hydrogen. So the product could be CH3C. We already have CH3. Okay, never mind. CH2 becomes CH3 because it have more hydrogen, so the hydrogen added to it, and this carbon will bonded to bromine. Okay, so this is the product that follow the Markovnikov rule. We call the reaction is an addition reaction because we add an atom to the alkene. So after the reaction, the number of atom in a molecule, we gain the number of atom in a molecule. Increase. Alright, so let's look at another example. Let's say we have this. And this is another one. Okay, now let's answer the first question. So first we need to focus on the functional group. When it undergoes reaction with HCl, let's focus on each carbon. This carbon and this carbon. Which carbon contain more hydrogen? So of course this carbon, meaning that the hydrogen will attach there. And the next carbon will attach to the chlorine. So the product the next one is this one. So let's focus on the functional group and then focus on each carbon. Actually, there is another one hydrogen here and there is no hydrogen here. So when it undergoes reaction, the bromine will attach here and the hydrogen will attach here. Okay. What happens if we have a compound like this, which is a symmetrical? We call it as a symmetrical. So bromine will attach to which position? So since it is symmetrical and each carbon contain equal number of hydrogen, where this is one hydrogen and this one also have another one hydrogen, so you can put at any position. Because when we give the IUPAC name, the IUPAC name would be the same for both. Okay, so this is direction that follow Markovnikov rule. So remember, when you have HBr or HCl or HF or HI, okay, you must follow the Markovnikov rule. But there is a situation where, okay, so there is a situation where, let's say, CH2 here. Okay, now only for HBr. Okay, only for HBr when there is another condition, either CH3, COOCH3, or sometimes we use ROOR, R represent the methyl group, or H2O2, which is a peroxide, it will become Anti Markovnikov. It's only for HBr in a presence of any one of it. Okay, what does it mean by anti-Markovnikov? If you follow the Markovnikov rule, the hydrogen will attach to the carbon with more hydrogen. But when it becomes the anti-Markovnikov, the hydrogen will attach to the carbon with less hydrogen. So in this case, so let me rewrite the equation. So we focus on these two. So which carbon contain more hydrogen? Of course this one. But the hydrogen will attach to the carbon with less hydrogen. Remember, anti-Markovnikov is only for HBr in a present either one of these. So let's say we have a cyclic compound, maybe like this. I always use methyl. R represent methyl. So in this case, when we look at HBr, then there is another group. So we focus here, and then we will look at each carbon, and then we can conclude that this carbon contains one hydrogen and this carbon does not have any hydrogen. So CH3 hydrogen will attach here because Anti Markovnikov, hydrogen will attach to carbon with less hydrogen. This is H and Br. Or we also can propose the structure like this. CH3 and Br here. Okay, so I hope this video will help you to understand the hydrohalogenation process. Okay, so you must follow Markovnikov rule or anti-Markovnikov rule, depends on the condition. And another one thing is, for this reaction is you're supposed to know the mechanism for the reaction. Okay, alright, thank you very much.